I taped and presented, so we'll see how that goes. So we have a tape of this. Ugly face in the corner. There I am. So 1.5, I know this comes out of nowhere, but this is the function chapter. And another thing that we like to do with functions is find inverses. So that's why this just kind of comes out of nowhere. But I just realized, like teaching 1.5 and 1 or period 5 and period 6, I use a lot of terminology that's been thrown around the whole chapter. A lot of things that's kind of like reviews. This is kind of a good little day here to you'll see those things and review those things. So give me a second. I forgot to click the attendance. It was so hard to do all these things. All right. Hopefully whoever's missing comes in at some point. All right. So you should be presenting here. All right. All right. So we're just going to get to the brass tacks of it and make it very simple. So when I say inverse, you say switch X and Y. I used to teach with Mrs. Cooper, what was called Cat Honors, and she would say, "No, you should say domain and range exchange." I'm like, okay, I kind of see a minor difference in that, but they're not really too much different. My thing saying switch X and Y actually physically tells you how you get an inverse of an equation. Before I continue, I don't know what the formula is. I can't think of it right now, specifically the numbers. My brain's dead, like I said. But there's a formula out there that takes Celsius and Fahrenheit, and you're able to plug in the Fahrenheit degrees, and then output is the Celsius. When you find the inverse of that function, it turns it into inputting the Celsius and outputting Fahrenheit. That's what inverse is. I just want you to think about that, not showing you the actual equation and doing it. That's what inverses kind of do in the real world. So there's an application for it. We're just going to give you the brass tacks in this world right now where we're kind of limited what we can teach. And then if it does get to be more complicated later, then at least you know how to find an inverse. Before I'm going to do this, I'm going to go ahead and graph this line because there's a graphical relationship I want you to know. And also, you guys are taking the ACT coming up, most of you. I'd be infinitely sad if you did not know how to graph a line or know components of it. So 2x plus 5, 5 is the y-intercept, rise 2, run 1. I'm going to fall 2 and run 1 to the left. All right, and then that's enough to graph a line. You should know that that's a line. We're just graphing it to show a relationship graphically with inverses. And then also find out that the domain and range of the original is all real numbers. So that's how you write that in interval notation. Not really a special question, but we'll go through the brass tacks of solving for the inverse or finding the inverse. Uh-oh, I hear somebody. Yes. Who's give the domain of the inverse of f of x, including any restrictions inherited. Okay, and actually we're going to give the domain and the range of the inverse. Okay, so yeah, sorry about that. It's not my writing. Borrowed some notes from another teacher, but not that my writing's any better. Okay, so I wanted to first tell you that f of x for sure is y. We just got to know that. That's what f of x stands for, a fancy word for y. And then we're going to switch x and y. And I'm sure you've done this in Math 3. I'd find it hard to believe, unless maybe coronavirus last year in March, April, May, your teachers weren't able to get to this concept. That could be possible as well. Who cares? This is what it is. Learn it if that's the case, if you haven't seen this before. You switch x and y, and then you resolve for y. I do like switching. 2y comes over here, x minus 5 goes over here, and then we divide by 2. And feel free to ask any question at any point. I'm going to turn this to green. The inverse of f of x is now what we want to write, instead of just an ordinary boring y. We call it the inverse of f of x. That's the notation. Remember this. If I say find f to the negative first of x, you're supposed to know that means find inverse. So make sure that you got that down as well. All right, I'm going to leave this. Nope, I'm going to change it to 1/2 x minus 5 halves. And I'm writing kind of slanted. I guess that's okay. And then I'm going to go ahead and graph this real quick. Y-intercept down 2.5. Now my scale is way off. I wish I had a grid here, but I'm just doing a real quick sketch. Rise 1, run 2. Rise 1, run 2. It's not going to emulate exactly what I want to see because of this problem with the scale, but we'll get there pretty good. Hey, those look like they have some sort of weird relationship. Like, if I kind of go slanted like this point doesn't go with this one, but But look at it. These are then it looks like there's some sort of um, symmetrical relationship, and there is. We're going to write this physically on our paper. I want you to know this. I know this is added to the thing, but we should at least know this relationship. This is actually the y equals x line. Why, you ask? The y-intercept is 0, and the slope is rise 1, run 1. So that is why that is the y equals x line. I'm going to get rid of all that stuff there. For inverses, the graphs of inverses, we're going to shorthand this notes because of our shortened time together. Graphs of inverses are reflections. This would be a nice little multiple choice question on the test about the y equals x line. Always. Okay? And we could see this in this first example here, and we're going to see it in all of our examples today. And by the way, you could look at the green line, and the domain and range is the same. So there's real no special relationship about what I can say about domain and range exchange. You're going to find that out in the next one, and the next one, and the next one. So real simple one. We're going to skip this one right now. This, Mrs. Westberg came up with a great idea because we have a lot of great questions. We were going over the test today. Like, what do we want to ask? Well, we can't ask this one anymore. We can't ask that one anymore. And really, we're losing the questions that I like to say separate the men from the boys and the women from the girls. You know, the ones that really separate the mathematical Marines that are, really going to move on to calculus and all that. Don't want to deprive you of that. So she came up with a great idea of extra credit questions during the 2 o'clock hour. And you physically have to write your answer, show your work, and flash it to the screen. And I thought that was awesome. So it leaves it open for people to come if they want, give it an attempt if they want, legitimately do it right in front of my face, and I could see you writing it, and then flash your answer to the screen, and I say, good job. And it's a one-time only affair. Come on, we know why. This world full of, there could be cheating and all this other stuff. And, so try to limit as much as we can as far as that is concerned. It does make us a little sad that we lose those. So I'm going to go back to that one. So we'll skip to this one. All the directions are find the inverse and then find the domain and range of the inverse. Good question. Whoever asked it, I forgot. That's what that said in cursive. Not just domain, we're going to find range. But before I do this inverse, I'll stick with blue with the original. This is why, we're getting review. Square root function. That's left 2. So the square root function looks like this left 2, or input, output. -2 plus 2 is 0, square root of 0 is 0, of course. That's the start of the square root function. -1 plugged in, plus 2 is 1, square root of 1 is 1. It really makes me sad how many students can't do that. I'm not talking about you because I don't know much about you guys right now. It really just does make me sad, those that cannot graph the most basic things. All right, domain. The domain, well, we just said it. I had to start with -2, -1, 0, 1. And then when I look at this picture, the range is 0 to infinity. All right, and then there we go. Range, y value that's covered. So we're going all the way back to 1, 1, and we're talking about those things. Or 1, 2. Sorry, we never looked at 1, 1 because it's a weird section. Now I'm going to go ahead, and this is what Mr. Samuels of the old did. He said, all right, remember f of x is the same thing as y, so that we can do the next thing, switch x and y, and then re-solve for y. How do I get rid of square root? I square. I know I'm going fast, but, we got limited time together in our little schedule that we have here. So square both sides to get rid of that square root. I always like writing this on the other side. Do the old switcheroo here. Okay, so y plus 2 equals x squared. Now that it's free, then subtract 2. And then go ahead and convert this back to inverse notation. And then what everyone should be saying at this point is, hey, that's a picture of a parabola. And if I were to graph that, this would be down 2 transformations. Hey, that's 1/6. And then it would look like this. But we got a problem, Houston. This came from the inverse of this. So let's look at that range and then talk about, this is supposed to be a complete and total reflection about the y equals x line. Domain and range exchange implies that the domain of the inverse must be the range of the original. And that is absolutely positively a rule with inverses. So I must restrict the domain so that the true graph of the inverse is truly, maybe I'll switch colors for the y equals x line. I don't know if blue and green really stick out anyway. Can't see much of a difference, but truly a reflection about the y equals x line. So we restrict the domain and can only graph half of that parabola to truly be the inverse of the original. So this you better mark down. This is definitely a test scenario. Hint, hint, that you need to know the domain and range after you find the inverse and remember this restriction part. And then, of course, the range, look at by default. If I look at this range, it is -2 to infinity. So that didn't change anything. That wasn't a restriction. It just happened. So there you go. Domain and range exchange is why Mrs. Cooper would say that, because that's what's happening when you have these restrictions. Let me move on so we can get back to that real tough, what I would call an extra credit question in the new world. All right, as we say. And then that's what the Samuels of the past said. You know what? That's y. F of x is the same thing as y. Now I can go ahead and switch x and y. By the way, don't freak out. This is not one of our functions that is on one of our 12. But I'm going to find the inverse of this, and the inverse is, then I'll show you that there are no restrictions. By the way, the domain, you should be able to figure out the domain for this. The domain, can I take the cubert of negatives? And the answer is yes. That little millisecond will let you think. You can certainly take the cubert of a negative. You get a negative. The cubert of negative is, like the cubert of -8 is -2. -2 times -2 times -2 equals -8. So there is a real world answer for this. Just proving that you can take the cubert of negatives, and that is a real world answer. There is no I on that. -2 times -2 times -2, something times itself 3 times equals -8. Not enough students understand that. So the domain and the range. If you can cube-root negatives and get negatives, then the range is an infinite amount of solutions as well. Well, that was wrong. From negative infinity to negative infinity, or positive infinity. My brain's starting to really break down now. I can't even speak words correctly. How do you get rid of a cube root? You cube it. What do you do after you cube it? You add 2. Wrong. I'm going to make this inverse of f of x equals the cube root, or x cubed plus 2. Oh my gosh. I think my brain's misfiring at this point. Things are just not coming out of my mouth that I want. We could graph that. Hey, that's the cubic function 2 up. And it looks like this with this little point of inflection there. Is the word I used yesterday. The cube root function does go through 2, 0. 2, 0 is the inverse of 0, 2. And it does kind of look like this. You don't have to know this, but compared to the last one, you might ask yourself, are there restrictions on the domain and range of the inverse? No, because there's no restrictions on the domain and range of the original. So I did kind of want to show that real quick. And then me snapping this picture real quick. Yeah, That's how come I knew what it looked like, because I'm reflecting over the y equals x line. I also know a little bit about the cube root function. Okay, and then here's our extra creditors. You should all know this because last year this was not extra credit. This was actually on the written test. Everyone was supposed to be able to do this. Then in the extra credit, we did a real complicated question that pertains to this kind of algebra. Well, maybe a little different algebra, but I think it has something to do with it. I'm going to rewrite this and then cover domain and range on this real quick. Hey, that graph right there is not there by accident. Hey, we're reviewing this as well. Look at all the review in this section 1.5. There's a horizontal asymptote at y equals 1 because these are equal in degree, so it's y equals 1 over 1. Hey, there's a vertical asymptote at -1 for x, so x equals -1. Review if you don't know that. If you don't know that by now. Okay, Mr. Samuel's getting angry again. I don't know why I switched to red. I don't care. Red, blue, who cares? Oh no, there's two y's. Every x turns into a y when we switch x and y. Joe, you all right there? Stretching over there? Okay, I thought you were going to fall off your chair. All right, so we got a problem. We got two y's. All right, so what do I do about it? I quit. No, you don't. You could cross multiply, or you can multiply both sides by y plus 1. They will both result in the same result. I said result twice. Ay, caramba. X times y plus 1 equals y. And then everyone should have a little recall of PR chapter, because we actually did do this in chapter PR. You distribute. You don't try to divide by y plus 1. You just multiply both sides by y plus 1 to get rid of that. All right, so no, you do something different. Let's try to distribute. Oh, okay, it's starting to come in now. I still have two y's, and I have to solve for one of them. What do I do? Oh, I remember. Chapter PR. I subtract the y to get it with the xy, and I get rid of that x by subtracting it to bring it to the other side. Then no, these y's don't subtract. That's like saying, I don't know, I can't even, I don't even, no, it just doesn't happen. You undistribute or factor out a y. And this is exactly a PR question that we had. And then the inverse of f of x, why is he writing that already? Because the last thing I have to do is divide by that x minus 1. Now, I'm not going to graph this one. We could. I just think for time we're not going to be able to. But let's look at the original. Here's the original's domain. The original's domain issue was x can't equal -1. If you don't get this relationship after all these examples, what's going on? Look at the range of the new one. These are still equal. Y equals -1 is the horizontal asymptote. So the range is the domain of the original. Domain and range exchange. And then the range of the original, that was that horizontal asymptote, y equals 1. So y does not equal 1. Sorry, that's a positive 1. There's another brain misfire. Zzz. This is like a little electrical impulse that went the wrong way. And then the domain, well, look at the domain here. X can't equal 1 because it has a vertical asymptote. So the domain of the original, wrong. The range of the original is the domain of the new. Range, domain, range, exchange. What a perfect end. Okay.